Hello friends, welcome to follow up. Let's have a look at the newly appeared problem 2674. Split a circular linked list. In this video, we're going to explain several ingredients for solving this problem. So the first one is a fast-slow pointer method, and the second one is a traversal and set method. First, let's look at the problem statement. So here we are given a circular linked list called a list of positive integers. So our task is to split it into two circular linked lists so that the first one contains the first half of the nodes. And here we need to use still, right? And in the same order they appeared in the list. And the second one contains the rest of the nodes in the list, and in the same order they appeared in the list. So the requirement for the return is the following. So we need to return an array answer of length 2, in which the first element is a circular linked list representing the first half, and the second element is a circular linked list representing the second half. So it's very important to notice that we need to return the two linked lists, but the two linked lists are required to be circular. So here a circular linked list is a normal linked list, with the only difference being that the last node's next node is the first node. So here we have two examples. So here we want to notice the length requirement. So here the length, there are 3 nodes, and the first linked list should have a length 2, right? In other words, it includes 2 nodes. So here in example 2, the number of nodes is even. So in the first one, it should include 2 nodes. So with that explained, let's also look at the constraints. First, the number of nodes in list is in the range given by the closed interval, so 2 and 10 to the power 5. So it contains at least 2 nodes, and the 10 to the power 5 gives us the problem size upper bound. So the node value is non-negative and bounded above by 10 to the power 9. And here the last constraint is basically explaining or emphasizing the circular nature. So another thing we want to point out is that the node value the node values are not required to be unique. So with that said, let's look at the method or analysis. So here what I'm going to do is to use 2 ingredients. So 2 ingredients. So one is a slow, faster pointer method. So this one basically, because we know the linked list is a circular, so we specify a slow and a fast pointer, and then when they meet again, basically we find the length of the or we find the number of nodes in the circular list. And the second is basically linear traversal. So we just need to use this linear traversal to get the correct node and do the reset. So these are the 2 ingredients. So with that explained, let's look at the coding part. So I'm going to first write a utility function, so to find the number of nodes in list. So this is actually very routine. So here I'm going to define this function as find length. So here we accept a height, right? And then notice that this is a circular linked list, right? So first I'm going to initialize a variable called result. This is for counting purpose. We are going to return the final state of this this result. And then we get a slow pointer and a fast pointer pointing to head and the beginning, right? Then I use a flag variable called catch. Originally is false, right? Then we do this. Well, not catch, So we want to find the next time the slow and fast pointers are equal, right? So basically we want to do slow is slow next, and fast is fast next, right? So each time we move forward one step, we're going to increment the result by 1. And then if we find slow and fast equals again, so we change to catch this flag to be true. Then this basically will be a stop. So afterwards, we just need to return the result. So this simple function, so here we use the slow fast pointer for checking the length, for finding the length in a circular setting, right? So after this, what we are going to do, let's first find the number of nodes. So in nodes, let's just call this function find length. Here we give this argument, and then the first list length will be this. First list length will be, because we want to compute the seeding, right? So we are going to do this, just to +1, then do integer division. This will do the job. So this is the first list number of nodes, I would say. This is more precise. So here is number of nodes in the first half. Next, we just need to do the resets and do a linear traversal. Linear traversal and reset. So for this, first let me get second list height. I'll first set it to be null, then I will just reset it during the procedure. So let's use a current to be the current height, and the count is 1. So counting the current nodes, right? And then we are going to do this. Well, true, what we are going to do. So first, I'm going to check if the count equals the first list length. If this is the case, so we're going to get the second list height will be the current next, right? And then what we are going to do, so because the current node will be the last node in the first half, we're going to set the next to be the height, and then we're going to reset the current to be the second list height. And in this case, we're going to do the count by 1. So this is the one case. Another case is the count equals the number of nodes in the full list. So in this case, the current node will be the last node for the second list. Then in this case, we are going to set the current next to be the second list height. So here, then what we are going to do is to do the break, and otherwise, so we just need to do current equals current next, and count incremented by 1. So then what we are going to do, we are going to return the first list height and the second list height. This forms a solution format to this problem. So here, let me comment on this height. So we need, this is a circular requirement, right, in the return. So similarly here. I guess with that said, let's first do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here in this video, for explanation purpose, we write the code in this fashion. So we first write a utility function to find the length. That's the one step, and then we determine the first list length, and then we do the traversal. Once we arrive at the first list tail, so we are going to do the reset. And once we arrive at the second list tail, we are going to do the reset. Otherwise, in between, we just need to point to the next node and increment the counting by 1. And finally, we do the return. So this way of writing is good to do explanation, but for sure, this code can be greatly shortened. So we encourage you to have a try, and maybe you can comment and share below the comments. With that said, I guess that's about it for this video. Thank you.